You know, Albert Einstein once said that everyone is special, but if you judge a fish on its ability to climb a tree, it will go through life believing that it's stupid. G'day everybody, welcome back. This will be a little bit different. It'll probably polarise a few people. If it's not for you, this content, just don't watch it, leave now, and go away and watch whatever it is that you do like to watch. So Albert Einstein, yeah, he said that, but he died in 1955. Now, if he'd have been around today, he would know that that fish would have attended a tree climbing class, and he would have got a participation medal and gone on to believe that he could climb a tree, and that is a bit of a problem. So what happens if that fish has such a narcissistic personality that it believes it can climb a tree? It blocks out any suggestion otherwise and would actually like to impart its knowledge onto other fish. It ends up transforming into a walking eagle, which is a bird that full of shit it can't fly. My mother always used to say, when we were kids, always used to say, beware the Pied Piper. Now, by that, she meant these kind of guys. So, you know, anybody that's in prominence or in influential positions that can march the rats. And you know, it's a not a bad philosophy to live by. Now, YouTube is a wonderful platform, and it's certainly changed the way that people learn and do research. And for our genre, for the motorcycling community, there are a lot of guys out there who are trying to save dollars on dealership costs and do maintenance themselves on their own bikes. And there's also lots of guys that are buying older bikes that they coveted in their youth or had in their youth and are reliving that experience, who are looking for videos on YouTube to help them through the process of doing, you know, routine maintenance, repair, or modifications to their bikes. And there are a ton of really good motorcycle-based YouTube channels out there, heaps of them, and I think it's wonderful. But the problem that I've got with it is that it's very difficult to try and differentiate between people who actually know what they're doing and know what they're talking about, and those that, well, to be frank, don't. Now, most of you that follow my channel will be aware that I am not a fan of Delboy's Garage. And before you all start on jealousy and all the rest of it, that's not the case at all. Let's look at the good things that Delboy does. So Delboy was lucky enough, I guess, to put himself on YouTube very early on in the process. So it's a bit of a case of the old, you don't have to be the best, you just have to be first. And that's quite common with fast-moving consumer goods sales. So you don't have to be the best in the market, you just have to be the first in the market, establish that market, that customer base, and build on that. And then others that come in behind you, you know, it would take some convincing for you to change over to their product. And I feel it's a bit like that with Delboy's Garage. So he got in on the platform early. He obviously saw an opportunity there where he could do simple maintenance on a motorcycle and maybe, you know, put the fear factor out of it for a lot of people that have never turned a spanner on a motorcycle in their life. And when I say simple, I mean simple. So you'll never see Delboy delve into anything particularly difficult. Like he won't pull apart an engine. I've never seen him do it, or delve into a gearbox or anything like that. So he does the simple things: brakes, suspension, you know, silly modifications, gluing beads on his bike and what have you. So that's and all that's fine. Taken in context, all of that is fine, and he's done a pretty good job with it. So he's built a good subscriber base. The one thing that you can't knock him for is that he hasn't tried to refine the presentation quality of his videos and come across a lot more professionally. He's achieved that with the help of the likes of Sealy and Wiimoto. And those guys who are all over Delboy, blowing in his ear, don't give two shits about Delboy. All they care about Delboy's garage is the subscriber count at the bottom. So they know, and the number of views that happen on his videos. So they know that there's a broad customer base of non-technical people watching his videos, and there's a marketing opportunity. So they flood him with trinkets, and they own his ass. So, you know, he does the whole presentation where he opens the drawers, and we've got the Wiimote. It's so painfully obvious now that it's nauseating. But, you know, all power to him. Good on him. And anybody else in this situation, you know, you'd say, good on you. Away you go. Have fun. Everybody else enjoy it. Going back to the whole jealousy thing and all the rest of it, I couldn't give two shits how successful anybody is. This isn't a competition. It's not like I'm in business competition with somebody and I'm trying to capture market share. That's not the case at all. This is a bloody hobby that I started this channel because I live remote from most of my family and friends from back in the day, and I wanted to be able to share with them essentially what I was doing with my XS 1100. That's why I started this channel, and it's grown from there. So then you end up with this audience base and subscriber base where you almost feel obligated to continue to provide content, and I enjoy doing it. It's not a labour. I do enjoy doing it. Every now and then I need to pull back a bit because it starts to become overbearing, but I enjoy doing it. So, you know, all the other motorcycle channels out there, I do enjoy watching them, and there's a lot of good ones, as I mentioned earlier. So why do I have such a problem with Delboy? The difference between non-technical motorcycle people who have motorcycle channels doing and are actually working on motorcycles and Delboy is that most people will put their hand up and say, I've got no idea. And not only will they preface their videos or whatever it is that they're doing with a statement similar to that, they maintain that. Delboy has such a bloody ego that he will continue to waffle on with a term that I now refer to as Dellsplaining. So Delboy gets an idea in his head, and 9 times out of 10, it's wrong because he has no technical base to work from. And that's not his fault. Well, it is his fault because he could go and research. He could go and do some bloody homework and learn a little bit more depth about certain subjects rather than a breadth of knowledge. He has a fairly good breadth of knowledge, but very little depth. It's shallower than a car park puddle. So he gets himself into strife because he'll go down a rabbit hole and start Dellsplaining and just ends up looking like a complete goose. And that's okay too. Go and look like a goose. But where I have a problem is all of those kids that are watching, or you know, guys that are older and getting into this kind of thing for the first time, or they're all watching that and taking it as gospel. Why? Because he's well presented. He manages his comments so that there's no negativity or there's no discourse within the comments, allowed to be able to put an objective view across, or any kind of argument, present any kind of argument. So he completely sanitizes the environment that people are sitting in and watching, and they believe what he says. So they go forth and they go and replicate or follow his advice or do whatever, and would quite often get people, I can imagine, will get into strife. I often have people contacting me asking questions relating to the video via my Facebook page, messengers and what have you not, or within the comments themselves, where they've attempted to do something and require further assistance, further advice. I could nearly guarantee old Delboy, he would have tons of that, because there's a lot of people watching that don't have a clue, and they're going to be reaching out to him, and I would really like to be able to be privy to the conversation back and forth between Dell and his subscriber base, because I think it would be reasonably entertaining. So let's have a quick look at where things go horribly wrong. Before YouTube came along, before the internet was invented, we had to use books to do research, and that can be difficult because you need to really be able to narrow down and try and find the right text for what it is that you're researching. However, the benefit of it is, if it's in print, generally you can trust it to be accurate. In terms of engineering and mechanics, you can generally trust it to be reasonably accurate. Some workshop manuals, etc., can be a little bit copy and paste. It's probably the best way to put it, but generally they're sound. If we look at a video that he did fairly recently on this Hayabusa that he's working on the steering stem, he changed the bearings in the steering stem. It's a perfect example of where we do a bit of Dellsplaining, we do some butchery, and then we tell other people how to do it. One of the places in that video where he starts waffling is this.
Okay, just a quick one before I start reassembly. Why go from ball bearing races to taper roller bearing races? And that's because these are better in every way. Taper bearings are smoother, silkier, they last a lot longer, and they're a little bit more maintenance free. These ball bearings, they live in this little kind of recess here, which is curved. It captures the little ball in the ball bearing ring. You put that in and it presses down. Now, these have to be done up. They have to be torqued up to a critical pressure. Too much and they'll bind and grind and the steering won't glide at all, and not enough and there's free play. And the distance on your tightening process between not enough and too much is literally a hair's breadth. So getting them right can be an absolute challenge. But taper rollers, on the other hand, if they're properly greased and correctly installed, you just tighten them down and they'll last. If there's a little bit of free play, you can just tighten them down a little bit more, but very rarely do you ever need to do that. I've never needed to do it, but I have heard people do. The reason is that you've got this massive area inside here, it's about 12mm from top to bottom, that the rollers bear against. So as a bearing weight and pressure, it's better able to take it and to last longer. A tiny ball bearing against a tiny little area there, it's going to wear quicker, and it's so easy to over tighten them. So bearings, if you're going to go for these, be prepared for a little bit more hard work to keep them correct. Obviously, taper rollers available from everywhere, no more expensive and last longer. So why wouldn't you? Why wouldn't you?
Yes, all right. So they're a roller bearing, a roller angular contact bearing in the steering stem from Suzuki, from factory. Now, there would have been a team of engineers that put the design concept up for that particular steering head. It's been a developmental thing across motorcycles that they've manufactured over many decades, and they know what works and they know what doesn't work. Was that bearing that they put in there the initial design? Who knows? At some point, procurement are going to get involved and say, well, look, we can use this carryover part from this bike, or we can buy these at a much cheaper rate. Can we modify it to suit this bearing? Da 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 da. So, you know, other influencing decisions do come into play when they're at the design stage, but at the end of the day, they will arrive at something that is fit for purpose and is more than adequate of handling the loads and the stresses for the design. Do they account for you doing wheel stands and smashing your steering stem bearings to bits? No, but they shouldn't have to either. But having said that, generally vehicle manufacturers over-engineer. They'll build something that is practically indestructible, and the reason they do that is they don't want recalls. However, I've noticed recently, in recent years, particularly around motorcycle manufacturing, not so much the Japanese, but are a little guilty of it. They'll just put the bloody bike out there, and if it fails, they will recall it, fix it, modify it for the next model, and that problem will be gone until the next problem arises. That seems to be a thing. Yeah, so Delboy talks a little bit about how the ball bearing arrangement that Suzuki engineered, designed, and built into the bike is feeble and weak. For whatever reasons he came up with rattly balls, I don't know, I can't remember. And why the tapered roller bearing is far superior. And look, you know, in the right application, both bearings are perfectly adequate, and they are good tapered roller bearings, but not for the reasons that he's explaining. Dellsplaining. Let's have a quick talk about books. Just cover up my surname. Don't need to be advertising that. Right, so this is a Zeus book. Got it when I was an apprentice, actually. Very good, fits in the pocket of your overalls, and very good in machine shops, or just a general reference book you can throw in your toolbox. Good in machine shops because they give you a lot of reference material in here, and they have a coating on the pages that makes them waterproof and resistant to splashing them with soluble oils and coolants. Throw it on the ground. So what we've got here is standard drill sizes and decimal equivalents. So your fractional measurement for drill sizes, 1/8 of an inch, etc., and the decimal equivalent of that. We also have the metric equivalent of that size. There's all of the different threads: isometric fine, isometric coarse, Whitworth, UNC, UNF, all of those, BSF, all of those threads. What the outside the diameter is, the outside diameter, the core, the pitch, the depth, the radius, the effective diameter, and the TPI, threads per inch. That's all very useful if you're setting up a lathe to do screw cutting and grinding a tool to do that. There's also the corresponding tapping drills for the different size threads, so that's also quite useful. And we continue on: more threads, more tapping drills, isometric, coarse, all the information you need for those. We have ISO fits, whole basis ISO fits. It's a fairly brief example of different fits, and it ranges from clearance to transitional to interference fits, and gives you all of the details around what those fits are. And that's useful if you're a machinist and you're given a drawing and it doesn't have a dimensional tolerances on a particular whole base fit arrangement on that drawing. It might just say H7 whatever. So then you can refer to this and actually get those dimensions and tolerances. And we'll talk a bit more about this later on. There's also a hardness comparison table. And something that I've used quite a bit over the years is this PCD measurements for hole positioning. So you can, it gives you dimensions for 3 holes on a PCD, 5 holes on a PCD, etc., all the way up to 12 holes on a PCD, and how to accurately, spot on mark out that for flange drilling. Morse tapers. So if you want to machine a Morse taper, you look up a number 2 Morse taper and you can get all of the dimensions that you need to do that in here. All of this, I'm not going to go through all. We've got all of the logarithms, sines, cosines, tangents, all of that sort of thing as well. Are all listed in this one little book. Algorithms, logarithms. A little bit of trig in the back for solving for triangles, for finding different angles and different sides, and how to apply the formulas for those. So very, very useful book. I guess further to that is this guy, the Machinery's Handbook. This is the daddy, in my view. This is an extremely good publication. Very, very useful in any workshop environment. Downside to it is it can be difficult to navigate. You've got to really sort of know what you're looking for, and but it contains just about anything and everything you will ever want to know about industrial engineering. Must have. I keep this at work as I do the Zeus book, and is a very good reference if you need to understand anything further than just surface level, and that's something that the Delboy really doesn't do. So if Delboy did go and do a little bit of research, he wouldn't have stated this.
And it's literally rusted out that bearing cup. They're stainless steel, but it's obviously still corroded. It's worn through the surface, and it's in a right old mess in there.
No, they're not stainless steel. They'll be 52-100 chrome steel. That is the material that most ball bearings are made from. So, see the problem here? Nomenclature matters. There are naming conventions for all different types of fields within engineering, and it's been done specifically for a reason. And that is that, when you're communicating around the world, doesn't matter who it is you're talking to, a supplier, or you're looking for information on something, if you use the correct nomenclature, you will be taken seriously and you will be able to find what you're looking for. That's an important thing. So when you say stuff like this,
inside the basket, not touching the basket.
If you're anybody technical watching that, anybody that has trade experience and above, are going to shake their head and go, this guy doesn't know what he's talking about, click and move on. The problem is that those that don't are just like this. Dell knows so much. Getting back to the bit about people who have some humility and say, look, I don't really know what I'm doing here. And then they maintain that throughout the video. Dell will occasionally say that, but then he goes on and says things like this.
There's one of them stuck to or pressed onto the spindle. Should I get that out?
There you go. I'll show you. So what did he do in that case? He's got the steering stem. I don't have a problem with the way he disassembled that steering stem at all. No problem at all. He did it perfectly fine, and the way anybody would do it. I don't even have a problem with the way he removed the inner ring from the bearing. And we're getting back to nomenclature again. The inner ring, which is sometimes referred to as the inner race, is actually, the actual correct name for that is inner ring. The race is the groove that the bearing rolls in. So the race is actually a part of the inner ring. So he removes the inner ring with a Dremel, cuts it, splits it with a chisel, slides it off. Not a problem with that. No problem at all. With the exception that he smacks the bloody steering stem with the chisel because he just wasn't being careful. I mean, that thing should have just almost been able to slide off by hand, or with something softer than the steering stem, like a bit of brass or a bit of nylon or a bit of timber, and just tap it off the steering stem and he would have been fine. But no, he had to go and clout it with the bloody cold chisel. Then, when he reassembles it, this is where I really have a problem, because after Dellsplaining the difference between tapered bearings and roller bearings without having any real knowledge about what he's talking about, he goes on to belt that bearing on with a hammer. Now, yes, he did use the inner ring from the original bearing as an interface between the hammer and the cone of the tapered bearing. But by not putting a piece of pipe on top of that again and extending above the stem, he's managed to hit the shaft with the hammer. And not just once. Have a look at this. He's absolutely pummeled that poor thing. So we've got the original roller ball angular contact bearings, got rid of them, and we've put in tapered bearings. I've just deleted a heap of stuff that I was waffling on about, because this isn't the time or the place to get into that. But suffice to say, we have an indirect mounted taper roller assembly. So the bearings are facing each other, and we're putting them into a housing. And that housing is made from aluminium. So it's an indirect mounted bearing arrangement on the steering stem, which means that the cone, the tapered bearings are facing each other. A direct mounting is when the backs of the bearings face each other. That's indirect. So we can expect that there's going to be preload of some description on those bearings, or free play, depending on the design. And I don't have a problem with the way that he put it together, with the exception of the bearings were poorly packed. Poorly packed. That's not how you pack a bearing. This is how you pack a bearing. You've got to make sure you pack them properly. So we show people, I'm going to show you how, we show people how to badly pack a bearing, how to put it on the shaft and damage the shaft. And then we go to throw the cups into the housings, and we start Dellsplaining again about heating and cooling, like refrigerating the cup for the tapered roller bearing, and or warming up the housing.
Okay, very quickly, a couple of things if you can do this yourself. It's this whole concept or business of heating up the hole properly with a blowtorch and then putting bearings in the freezer. There's a couple of reasons I don't like putting bearings in the freezer. These rings, these bearing rings, in fact the outer part of any bearing whatsoever, is not designed to flex, ever. It doesn't have to be flexible and robust because it just sits in a solid hole. Look where that is housed. That bearing ring is housed inside a thick cast aluminium machine casting. It ain't going anywhere. So it doesn't have to move. Therefore, its only job is to be super hard and super solid. In fact, it can afford to be brittle. It doesn't matter if it's brittle because it's not going to flex anywhere and break. But if you freeze that bearing in the fridge overnight and then you come out, you've got a red hot hole, you just heated up with a blowtorch, you go putting that in for nothing more than laziness and convenience. You can push it in with your fingers. Yep, fine. Okay, there are other methods to put bearings in, but if you're going to do that, think about the temperature change, that sudden shock of the red hot metal against the freezing cold metal out of the fridge, one against the other. The temperature change in the outside of that steel is suddenly instantaneous. So ask yourself the question, is that liable possibly to shock that steel to either make what is already a brittle, super hard steel even more hard and more brittle and fracture and break early, or on the other hand, could it even make it soft? Could it partially anneal it because you've heated the outside of it and then it's cooled down at its own time? That would be all bad because then it would wear out in a matter of months, and it could even lock up because if you get a piece broken off the inside, that can lock up the bearing and stop it moving. And that's right on a wheel. Okay, it locks the wheel, you might get away with it. You lock your steering because it's locked against the broken bearing when you're driving along. You can work out the rest, can't you? So heating up the hole and putting in a fridge bearing, I don't do. And the bearing at room temperature only, no more harsh than that. But you do what works for you.
Now, going back to books and fits, this particular book here, if you delve into this, you can find very easily the coefficient of linear expansion and the delta T required to achieve whatever amount of expansion you are looking to achieve, expansion or contraction, because it works either side of 0 degrees centigrade Celsius. So you can find that information in these books. You would know what temperature you would need to bring your steering stem housing up to in order to be able to drop the bearing in. Suffice to say, home workshop, you know, you go and I've done it myself, where I put a bearing into a freezer or a refrigerator and bring the temperature down, and or warmed up the housing to a couple of 100 degrees to be able to drop the bearing in. The steering stem bearing is probably somewhere between a transitional fit and a mild interference fit. So there's not a lot of load on that bearing. You wouldn't need to heat it up much to drop it in. To say that it's just because of laziness, that's ridiculous. That aluminium housing, the more times you smack a bearing in and out of that, it's softer than the bearing, and the more times you do that, the more it's going to wear out, and eventually it'll get to the point where that bearing will, that cup will spin in the housing, and you'll need to put Loctite bloody retaining fluid in there, or machine it out and put a sleeve in it. Then we go on about thermal shock. That's ridiculous, absolutely ridiculous. It's not going to happen. In fact, you can buy commercially available bearing warmers that heat bearings right up in order to be able to put them over a shaft. And I have had to heat bearings and fit them to shafts all of my working life, and quite often big diameter bearings, and that have to go a long way down a shaft, and it doesn't take much interaction between the shaft and the bearing for the heat to transfer into the shaft and the bearings start to shrink. So you've got to be bloody quick getting it into position. But I have never ever seen any damage to shaft, housing or bearing from the normal heating and or cooling of transitional or interference fits. Absolutely ridiculous. And if you have a look at your book and work out what temperature you need to have your housing at in order to expand it X amount of thou, and you can measure the whole thing and work out what the difference is between the housing and the bearing, then and only take it to that temperature, well then what's the problem? You don't need to heat it red hot. So then we have another Dellsplaining episode of setting the bearing. And it's true that sometimes tapered bearings do need to settle in a little bit, but not this.
So the first thing to do is get your C-span, and I can lean on it and do it up nice and tight. Now the purpose of doing that lock nut, or that ring up really tight, first of all, is to push the two bearings into place, to seat them effectively, to get them right into their grooves, ooze any spare grease that I've put in there, and that grease doesn't want to be in between bearings and faces. So as you squeeze it in, it forces it all out of the way, and you've got a nice, practically metal to metal finish with a thin layer of grease between. Correctly. It does give you a torque setting in the book, but I like to set it very much like the swing arm, by feel. Nip it up till it's a bit too tight, back off till it goes loose, and that's the sweet spot right there.
Yes, there are torque settings, but it's a different bearing, Dell. The torque settings are for the original factory bearing, not the one you're talking about. And again, this is an area I don't have a problem with, because more often than not, unless it's critical for thermal expansion and loads, where it's specified, you will have to preload bearings or leave end play, clearance, end float on a shaft, for example. But generally speaking, for these types of applications like swing arms and steering stems, the taking the clearances out and actually having a bit of feel about what sort of resistance you've got on the bearing is fine. But do we squash them and take all the grease out for metal to metal contact? No, not that there's any grease in your bearing anyway. So there's been a number of videos. Matt attacked Dell about one where he was treating a screwdriver, heat treating a screwdriver, because essentially what Dell did was harden it and made it very brittle, but he didn't temper it, and he doesn't understand metallurgy at all. He's got no idea about the transitional stages. If you've got steel and it's bright, when you heat that, it forms an oxide layer, and that oxide layer is transparent, but it allows light through, and the colour will change in that oxide layer at very specific temperatures, which is why for the last couple of 100 years, blacksmiths and metal workers have been able to determine what temperature different steels are at simply by the colour. Now, it is it can vary with alloys, but it is a good general rule of thumb without the use of proper temperature measuring devices or thermal crayons or anything. So you can tell by the colour what's going on, and you can also tell fairly generally with ferrous metals when they reach what they call a critical temperature, which is the temperature at which you want to do any hardening, etc. And that is when the material becomes non-magnetic. So something as simple as a screwdriver, like what Dell did, all he would have had to do was heat it until it was no longer magnetic. He would have known it was at critical temperature and could have quenched it and then followed that up by tempering. But Dell thinks hardening and tempering are the same thing.
And that metal becomes denser than it was before, so harder than it was normally. So you're hardening the metal, you're tempering it.
So if you don't understand something like that, and he says in this video,
this is a really old screwdriver I've had for a long time, and the state of that tip. That's only because it is just an old screwdriver. It's got no sentimental value, but it's a big handy thing. I use it as a pry bar and as a chisel and all sorts. But let me show you what I mean. I'll put a bit of a shape to that, and I'll show you how tempering it like this will make it work as a screwdriver again. We can rescue this, I'll show you. This is quenching from red hot to stone cold in oil, and that will make the metal hard and durable and resilient. And there we are, repaired a screwdriver. And I've done that to this screwdriver a dozen times.
Pry bar and chisel. And chisels are something that you don't have a uniform hardness, so they will be harder on the cutting edge and softer on the striking edge. Why? So it doesn't splinter and take your eye out. And that's the problem when you've got someone making a screwdriver hard and brittle like glass and then saying, I use this as a screwdriver and a pry bar and a chisel. Because monkey see, monkey do, goes to his bench at home, does exactly the same thing, pry, snap, bang, loses an eye, and Delboy's none the wiser, rides into the sunset. This is the problem. And I guess, all right, so he doesn't understand metallurgy, he doesn't understand basic engineering principles around rolling assemblies and bearings and shafts and housings, yet he wants to explain this to everybody. He doesn't understand, he doesn't know nomenclature, because if he did, he wouldn't look like a goose and call a roller retainer in a bearing.
But it mustn't come out too far so that it hits the bearing basket. It's just a little basket.
A basket? I mean, it's sort of generally accepted, I guess, even within industry to call it a cage, but basket? That's something that you have in your clutch or your laundry. So his latest video on the Hayabusa was trying to remove the bolts from the exhaust pipes, and remove the pipes. He's using some sort of freezing penetrant, which is supposed to be a penetrating oil. I don't know anything about it. It's a Worth product. Looks like it's probably some kind of nitrogen or something. I don't know, that it's using to cool the product. Theory is that it creates a temperature differential and allows it to free the fastener up. Not the right application for what he was doing, I don't think. He would have been better off using a little bit of heat in there, but he had a go trying to get these bolts out semi-successfully. Manifold bolts can be a bugger because of the heat cycling and corrosion, oxidization of the steel fasteners. So usually my best success with those types of fasteners that get stuck in on exhaust manifolds is to actually use an arc welder or a MIG welder if you've got a MIG on it. I've never owned a MIG, and just burn, put some weld onto it, tap it with a hammer, a bit more weld, tap it with a hammer, a bit more weld, tap it with a hammer. This is on the head of the fastener that you've just stripped and rounded off, and the heat plus the impact will free it in the cylinder head. You can grab the welded section with a pair of locking pliers and get it going, and once you get it moving, generally they come out pretty easily. That's if you've got a stud that's stuck in there, and again, if there's any Loctite, the heat will melt that Loctite. But Dell's had a go, and he's struggled to get half of them out. But then he came across this.
We've got a bit of a disaster. Unfortunately, this project just got a great deal more complicated and quite probably a great deal more expensive, all because of corrosion. Let me show you this. You see the crack, and that is a big terminal crack in the cylinder head exhaust port mouth, and it goes right the way around to 3 o'clock. There it is, you can see it's actually lifted up and it's going to break off. If that breaks off, the exhaust is just going to blow straight out there from the cylinder head and just be a complete mess. So that's not going to stand.
Yeah, it's a little piece of broken cast aluminium on the exhaust or outside of the exhaust port of the cylinder head. He's panicked about it, and this is his response. We have liability issues here. I bought this bike, and this is what I want to say to end this video. I purchased this Suzuki Hayabusa from a very good, well-reputed local motorcycle dealership. I've had a very quick phone call with them. The owner of the company is away at the moment, and he's not back at the dealership for 2 days. I'm going to have a chat with him on the phone in 2 days' time, and we're going to come up with a plan. So I will talk to you in the next video. I'll tell you what we've come up with, what the suggestion is, what we're going to do about this, because there's nothing, you can't neglect it, you can't just leave it. That has to be fixed, or something has to be arranged in some way. I don't exactly know what, but we'll come up with something. So he's going to go to the dealer and ask the dealer to do something about this horrible mess. Well, I hope he laughs in his face and tells him to bugger off and never come back. What you're looking at there is not a sealing face for the exhaust. It's just a housed section that allows that tube, that the flange, the manifold flange, compresses the exhaust seal with. It just basically holds that and retains it. So you're not going to get exhaust blowing out of there, like you said. You can just leave it. It's all tucked in behind a radiator and fairings, and you can't see it anyway. If you're really concerned about it, weld it up. This is something that he keeps forgetting. He's got a MIG welder. They do make aluminium MIG wire, even if you don't want to TIG it. And it's not that difficult to weld. I can prove that. This is the off the GS1000, off the master cylinder, brake side master cylinder. Took it to work and got the TIG out and melted a bit of TIG filler wire to build this up, because it did look like that. It had been broken off to build this up. So now I can shape this, drill and tap it for a rear vision mirror. It's not hard to weld aluminium. It's for me, it was just figuring out what to do with the settings on the welder. Back to the books. This one, king, absolute king. So Mechanical Engineering Design by Joseph Shigley. And this is a fantastic piece of text and will help you out in a lot of ways, particularly good if you are doing design. So where the other books, the Machinery Handbook, has similar information in it but is difficult to navigate, I find it difficult to navigate. The Zeus book is very high level. This one goes into very good detail. And if you're looking at designing a particular component and you're wondering what type of fit to apply, a running fit, a clearance fit, a transitional fit, an interference fit, force fit, this book will explain to you the applications. So you can, and it's not just fits. I mean, this book covers a lot of different aspects around mechanical engineering design, dealing with stresses, and there's lots and lots of formulas and plenty of information in here. But I'm just making a point around the mechanical fits, so the ISO type fits. So this book will help you decide which is the best one for your application, whereas these other ones tend to just give you dimensional information. With the Machinery Handbook goes into a lot more depth, but again, like I said, it's difficult to manage. So get knowledge. If you're a Delboy fan and you're watching this and you've got this far, choice is yours, brother. But I would take everything with a grain of salt. I think that this is a major problem for YouTube. I mean, YouTube don't care; they just keep pumping it out because it's family friendly and everybody loves it and da 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 da. But it's fake news, man. Dellsplaining, fake news. Thanks for watching. Don't forget to like, subscribe, and comment. Don't unsubscribe. I'll catch you next time. Andy's Motorcycle Obsessions. Bye for now.